Today we're going to look at how do we graph linear inequalities. So inequalities with both an x and a y in our coordinate plane. To build our understanding, we're going to look at two scenarios and determine if an ordered pair is a solution to an equation and then two linear inequalities. So we've got our x and our y, and to determine if it's a solution, we're going to substitute in, see if it holds true. So that's going to be 2, and we're looking for, is it equal to 4 times 1 minus 2? So that's 2 equals 4 minus 2. 2 equals 2. Yes, it is a solution. So that tells us the ordered pair 1, 2 is a point on the line, right? It's a point on the line, y equals 4x minus 2, because it is that solution. Now let's try with the inequality. Y is less than or equal to 4x minus 2. So that's going to be 2 is less than or equal to 4 times 1 minus 2. 2 is less than or equal to 4 minus 2. 2 is less than or equal to 2. That's true because of the equal to. So it is a solution. Now let's look to y is less than 4x minus 2. 2 is less than 4 times 1 minus 2. 2 is less than 4 minus 2. 2 is less than 2. No. So it is not a solution. So we've got a yes, and a no. Okay. So determine if the ordered pair 2, negative 4 is a solution to the equation or inequalities below. Okay, so different point now. Still have an x and a y. So we'll substitute in and see if it holds true. Negative 4 is equal to 4 times 2 minus 2. Negative 4 is equal to 8 minus 2. Negative 4 is equal to 6. Nope. No. Does not hold true. That tells us that the point 2, negative 4 is not on the line. It's not on the line y equals 4x minus 2. That's what it tells us when it's not a solution. Let's check with the inequality. Y is less than or equal to 4x minus 2. So we'll substitute in. Negative 4 is less than or equal to 4 times 2 minus 2. Negative 4 is less than or equal to 8 minus 2. And then negative 4 is less than or equal to 6. And that's true. Negative 4 is less than 6. So that tells us, yes, it is a solution. So even though that point 2, negative 4 is not on the line y equals 4x minus 2, it is a solution to the inequality y is less than or equal to 4x minus 2. Interesting. Let's try this one here. And this one, right, is also going to hold true. We say, yes, it is a solution. So there has to be some way, graphically, we can show a point that's not on the line is still a solution to an inequality. And we're going to have to take a look at Desmos to see how that looks, as well as how do we show a point that's on the line that's not a solution to an inequality. So a few interesting things going on there. Let's take a look. First thing I'd like us to look at is the equation y equals 4x minus 2, our linear equation, which I graphed here, and how we had the ordered pair 2, negative 4, and we said it was not a solution to the equation. If we see it, it's right there. There's the ordered pair 2, negative 4, and I can plot it if I'd like. Not cute. 2, negative 4, and that plots the point for me right there. And we see it's not a solution. It's not on the line. But we said it was a solution to our inequalities. Y is less than or equal to 4x minus 2, and y is less than x minus 2. So that brings into question, how do we show points that are a solution to something that's not on the line? And we do that with an inequality with shading. So if you see here, we shade, and we're shaded in the area of the point. The shading of our inequality shows all the solutions to that inequality. So all those points that are off the line that satisfy y is less than or equal to x minus 4. Now I'd like us to look at the equation y equals 4x minus 2, which I've graphed, and that first pair we looked at to determine if it was a solution, the ordered pair 1, 2, which is graphed there in blue. And we can clearly see it is a solution. But what we said was that ordered pair was not a solution to the inequality y is less than 4x minus 2. So there has to be a way we show a point that's on the line that is not a solution. And the way we do that is by using a dotted line with that inequality, the same way we use that open circle with our inequalities on the number line, right? So it's approaching, but not actually on that, okay? Whereas if we have an equal to inequality, we use a solid line. So we're going to go ahead and build that understanding as we go to our lesson in our book. Here I want to just review a couple of our inequalities we did back in November when we were working with our number line. So we had x is greater than or equal to 0, and we had our critical value of 0. We're going to put a circle. We're going to put a shaded or a closed circle because we have that equal to, right? So when we have that underline, that equal to, we use the shaded or a closed circle. When we go to do our linear inequalities, we're going to use that that solid line. Now, x is greater than 0. We say, okay, where are all the numbers greater than 0? They're all to the right, so we shade to the right. We shade to the numbers above 0. Okay. Then down here below, we have an inequality that we have to simplify. We have to solve for y before we get there to be able to graph. So we're going to distribute that negative. Negative y plus 5 is greater than 9. We'll subtract 5 from both sides. So we get negative y is greater than 4. Now remember, we don't want negative y, we want a positive y. So we're going to divide both sides by negative 1. Oh my gosh, dividing by a negative when solving an inequality, you have to flip or reverse that inequality, where now we're saying y is less than negative 4, right? So we put our number line there, just a quick number line we're making. Okay, now y cannot be equal to negative 4, so we use that open circle. When we go and graph our linear inequalities, we're going to use a dotted line to show the same idea of the open circle. Y is less than negative 4, so we're going to shade all the numbers less than negative 4, all the numbers below negative 4. Okay, so let's go put that all into practice now. Here on page 36, we're going to work on graphing our linear inequalities by hand. So our first step is going to be to rewrite our equation in slope-intercept form, that y equals mx plus b, but instead of having an equal sign, we're going to have some sort of an inequality symbol there. We want to remember that when multiplying or dividing by a negative on each side, we're going to flip or reverse that inequality symbol. Okay. Step 2, we're going to graph the inequality as a line, but we're going to look to the inequality symbol. If we see an equal to underneath it, where previously we would have done a closed circle for our inequality, we're going to use a solid line when we graph. If we see a less than or greater than, where we would have done an open circle, we're going to use a dotted line or a dashed line, not a full solid line, showing us it's not equal to. After we graph, we're going to look for what way we shade. Now, the way I like to remember it is if I see a greater than, I'm going to shade above the line. If I see a less than, I'm going to shade below the line. That's a new skill for us. So for now, we're going to use a test point to double check our shading, and we'll do that here in our example. As you get more comfortable and you get practice, you don't need to use the test point. Okay, so let's start here. We're going to have our graph. Y plus 2 is greater than negative 1/3 x plus 6. So we're just going to subtract 2 from both sides. y is greater than negative 1/3 x plus 4. So I see my inequality. That tells me two things. That tells me it's going to be a dotted line, because there's no equal to there. And it also tells me with that greater than, right? Greater than, we're going to shade above. Okay? So I go to my y-intercept 4. Start at 4 on the y-axis. And then our slope, negative 1/3. Right? That tells me go down 1 to the right 3. Feel free to go back and review our other videos of graphing if you don't remember how the slope works for graphing. So we're going to go down 1 to the right 3, down 1 to the right 3, and then the opposite, up 1 to the left 3, up 1 to the left 3, up 1 to the left 3. Now I'm going to create my line, but I have to remember I'm going to do a dotted line. So every time I go, I'm just going to pick up my pen periodically so I can see that it's a dotted line. I'm going to put my arrows. Many times students are worried that I'm not going to be able to tell it's a dotted line, so feel free to, kind of label it as dotted if you need to. Now we're going to go through and do our shading. Our inequality says y is greater than negative 1/3 x plus 4. So greater than, that means above. Where are the y values greater? So if I look at my y-intercept, where are the y values all greater? Well, it's above the line. So my guess is that I'm going to shade above. But like I said, it's a brand new process, so we're going to use a test point. Now the easiest test point to use is 0, 0, and I'm going to use that. You just cannot use a test point on the line. So don't use test point on line, because that would only reveal information about whether it should be solid or dotted and not whether it should be shaded. To use our test point, we're going to take our inequality from slope-intercept form. Okay, and that gives us an x and a y to substitute in. And we're going to see whether or not it's true, whether or not it's a solution. Our test point is here at the origin. I think I'm shading up here, so my guess is that our test point should be false, that it's not a solution. So let's see, so 0 is greater than 0 plus 4, 0 is greater than 4, false. So that tells me the test point 0, 0 is not a solution. Because it's not a solution, that tells me shade on opposite side of line. Our test point is below the line, we're shade the opposite side, above the line, just like we predicted. Now shading, do not scribble. You cannot scribble. We need nice controlled lines coming off. Tomorrow we're gonna graph multiple inequalities on the same page, on the same graph, so we need to be able to see. You cannot do crazy shading. So I just do nice controlled little lines up here through the coordinate plane. And the last thing I want to do is label my inequality, always labeling. And there we are, we're done. So let's take a look to example 2. First thing we're going to do, put it in slope-intercept form. So we'll have to divide everything by negative 2. Divide by negative 2. Divide by a negative, flip the inequality, right? We divided by a negative, flip the inequality. Negative 8x divided by negative 2, positive 4x. Positive 4 divided by negative 2, negative 2. Now I want to notice our inequality, greater than or equal to. So greater than or equal to, that tells me it's going to be a solid line. With that being greater than or equal to, greater than tells me shade above. So my guess is we're going to shade above the y, where the y values are greater, above the line, but we'll still use a test point. Okay, so let's go for, let's see, our y-intercept is negative 2, so we'll start at negative 2. Our slope is 4, which I want to think of as a fraction as 4 over 1. They're both positive, so that tells me I'm going to rise 4 and run 1 to the right. So go up 4, 1, 2, 3, 4, to the right 1. 1, 2, 3, 4, to the right 1. 1, 2, 3, 4, to the right 1. And then the opposite. I'm going to go down 4 to the left 1. Down 4 to the left 1. Now I'll take my ruler, create our line. It's a solid line. So worry-free, just go right through. Put my arrows, and now we have to think about our shading. Okay, so I look at my line, I find my y-intercept. Where are the y values greater? Because it's a greater than or equal to above the line. So I'm thinking I'm going to shade this way above the line. So that's where above would be, where the y values are greater. That's how I determine above. Okay, we're still going to do our test point. The origin 0, 0 isn't on the line, so I'm going to use that again. Why not? Okay, and we'll substitute in for our equation in slope-intercept form. Y is greater than or equal to 4x minus 2. Okay, so 0 is greater than or equal to 4 times 0 minus 2. 0 is greater than or equal to 0 minus 2. 0 is greater than or equal to negative 2. That's true. Okay, so that tells us the point 0, 0 is a solution. And that tells us to, or it confirms to us, shade on the side of the test point. And that's where we predicted shading, on this side also. So again, I'm just going to make nice controlled lines going through. Don't have to be super dark, don't have to be super close together. It's good that I can see through it, because like I said, tomorrow we're going to graph 2 inequalities on the same coordinate plane, and there's going to be an overlap and a cross-hatching. Last thing we want to do, label our inequality. And there we go. We've graphed linear inequalities. Now there's one thing I want to go over with you that we have not discussed today in our lesson, and that is, how do we graph a vertical inequality? So I'm just going to use the same coordinate plane. I want to say, how do we graph something like x is greater than or equal to 7? So I have to realize it's a vertical line. The only information I have is that x is 7. I know it's going to be a solid line, right? So I'm going to graph a solid line at 7 on the x-axis. Okay. Now typically when I see the greater than, I say, oh, we're going to shade above. But it's a vertical line. There's really no above. So think of it as x is greater than 7. Where are the x values that are greater than 7? They're all over here. So that's where we're going to shade, right? Think of it. X value of 8, 9, 10. Those are all greater than 7. Those are all solutions. So we would shade this way. Okay, so hopefully just a little hint for you. Now, you'll notice on your classwork on page 37, I didn't really give you much room to do a test point. So if you're using a test point, you want to use a piece of scrap paper for your test point. If you feel comfortable going with the above and below, feel free to do that. And then page 38 is a little bit of mixed review as we are preparing for our test on Friday. Okay? And today our review sheet is accessible on Google Classroom. Today's math jokes for mathy folks. Are monsters good at math? Not unless you count Dracula. Hey-o! Have a great day.